Alright guys, I was able to capture one. So let's be careful. Reach into here. Be careful not to destroy its wings. Look at that. These are very adept aerial predators, in the order Odonata, particularly the dragonflies. You see the legs are just covered with, they're covered with long setae. There we go. And that's to aid in capturing prey items. And so they'll grab them with their legs and just start chewing, start devouring them. You can see those large compound eyes that it has, just thousands, made of thousands of little facets called ommatidia. And each ommatidia has its own lens, which focuses light, and pigment receptors inside. This particular one is in the family Libellulidae, which is pretty difficult to say quickly. Sometimes the compound eyes of dragonflies can be sort of divided in half, with the ommatidia on the upper half a different size than the ones on the lower half. And this is essentially to aid in prey capture. Okay, so the visual acuity of the different size ommatidia is different. Okay, and this occurs in other insects as well. Not necessarily divided eyes like that, but there'll be different sized ommatidia positioned in various parts of the eyes. They might be on top or on the sides or even on the lower part of the eyes. And they can have different photoreceptors inside as well. So not all of the ommatidia within a compound eye necessarily will pick up all the same type of light. And you see, dragonflies are just really beautiful. I mean, their wings are just, you see all the veins in them. This sort of pattern is called an archidictyon, this dense patterning of veins. And they're just extremely agile flyers if you've ever seen them. Odonates these days, well, they can get fairly large in size. But essentially before the Permian, you had a whole entire superorder that were these giant sort of dragonfly looking insects, and they were in the group Paleodictyopterida. Now these resembled dragonflies, but they weren't really related to them. Many of them had beak-like mouthparts, and the aquatics, the immature stages of them, we're not really sure what they did, whether they were aquatic or not. And various groups of these Paleodictyopteridans, unfortunately, they went extinct at the mass extinction in the Permian, at the end of the Permian. So this entire superorder went extinct at the end of the Permian. And for a while, they were the only aerial predators. And many of them were pretty massive in size. The largest ones being up to 70 centimeters in wingspan. So you're getting close to a meter wingspan size. And what's left really of the relatives of that group are today's dragonflies and damselflies, the odonata. Really spectacular organisms. Also, if you ever look at a dragonfly close up, sometimes you can see the abdomen pumping. It sort of becomes flat and it expands a little bit. You can see it slightly here. You see the abdomen moving a little bit. Okay, so what it's doing is it's actively breathing, essentially. It's also pushing blood and hemolymph to help it circulate within the body. You can see it a little better ventrally, actually. You see that abdomen? It's expanding and contracting. Yeah, that's because inside it's filled with these tubes called trachea, as well as air sacs. Their entire body is just filled with air sacs. And so this pumping is helping squeeze, helping force through air to different parts of the body. And this helps regulate the temperature, okay? As well as it pushes gases throughout the body, the oxygen and CO2 after they breathe. Since they are such active flyers, they need this type of body ventilation. Really impressive. And of course, odonates are not the only ones that do that. As we'll see maybe later, all sorts of insects will pump different parts of their body, usually the abdomen, but other parts as well, maybe in the thorax, to help ventilate their body, to push blood and to push air through. Very nice. Let's let this one go. And off it goes, probably to patrol its same territory.